What's up, everyone? This is LeetCode 146 LRU Cache. We've done this problem in Python. Now it is C++ time. Um, so we're gonna go over this very briefly, very briefly, and then I'm gonna just reuse my explanation from my Python video. It's language agnostic, because it's just an illustration on how we're gonna approach this problem. Okay, and then we're gonna code it up in C++. So we have a data structure that follows the constraints of an LRU cache. Then we basically just have to implement the class, right? We have a constructor where we have to initialize the cache with the positive size capacity. Then we have the get function where we have to return the value of the key if it exists, otherwise return -1. Then void put where we have to update the key if it exists, otherwise add the key value pair to the cache, and if a number of keys exceeds the capacity of this operation, evict the least recently used key. The difficulty of this problem is really that we have to do everything in O1 time complexity. Okay. It'll make more sense when you code it up, but I'm just gonna go through to the illustration now, and then yeah, we'll come back and then we'll code it up. All right, now we're in this illustration. I'm gonna basically explain this LRU cache. So you have this visualization here, right? So as you can see, right, like this example, our cache capacity is just 4, right? So we have a capacity, right? And then we have basically two functions we want to implement, the get and then the put, okay? But before we go into that, as you can see, we're actually going to implement a hash map and a doubly linked list to kind of approach this problem, and I'll explain why, okay? The reason we're going to use a hash map is because, again, this problem has to be an O1 time complexity, and hash maps give us fast lookups, right? So because hash maps gives us fast lookups, we're going to use it, right? So for specific keys, right, it'll give us fast lookups, and then the value is actually just a pointer to a node, rather than an actual value. Now, the reason we're going to use a pointer to a node for the actual value on the hash map is because we need to know exactly where we're going to remove certain things, right? And for that to be O1, right, we're going to use a doubly linked list. So the lookup will be fast by using a hash map, right? And then the removal stuff really, or addition stuff, that's all going to be in a doubly linked list. So again, we can maintain this O1 time complexity because it's kind of the entire point of this problem. Okay. So why a doubly linked list, right? We can maintain the pointers and handle the most and least used efficiently. So we need to add and remove, and the remove really happens based on the capacity. But not always. And I'll explain why. Okay. So in terms of our doubly linked list, you can see, right, we on one end we have the least recently used, and then on one end we have the most recently used, right? Okay, so keep that in mind. So again, we're using a hash map, we're using a doubly linked list, right? Because the hash map gives us O of 1 access, the doubly linked list gives us O of 1 ordering. So, right, the hash map's just for lookup, then the doubly linked list is kind of where we maintain kind of our cache and the order of from most recently used to least recently used. Okay. So if you remember, we have a get function and we have a put function. Okay. I'm going to explain each one and kind of how this kind of cache is implemented, and how it will work with these functions. Okay. So for the get, if you remember, I'll just explain in case you don't have it pulled up, but for the get function, we basically have to look up a key and we return the value of the key if the key exists. Otherwise, we're going to return -1, okay, for the get function. The way this is going to work is basically we're going to check if the key exists, right, in the hash map, because again, the lookup is really fast, okay? And if it doesn't exist, we return -1. And if it does exist, what we're going to do is we're going to check what node does that key point to, okay? So let's look at this thought exercise, right? What happens if we get T2, and get, right, is the actual function. So we're gonna get, I guess I put T2. These are actually these are K's here, but the T2 is here. So we're gonna get T2. So we're gonna go here, Okay, technically the value is T2. The actual keys are K's, so technically this should be K, not T2, but it's besides the point. This is just for an example, but so we're gonna say, okay, K2, we're gonna get K2, boom, right? What does it point to? It points to this right here. Okay, so when we access something, right, with the get function, that's basically us using it, right? So what we would have to do is we would have to remove this and then add it at the most recently used, right? Right? So now the order is like this, okay? So now this T5 here, I think I said T2, I meant K2, but this T5 here is it now went from least recently used to most recently used, right? Because we just accessed it with the get function, right? And the way we basically reorder stuff in the doubly linked list is we remove it and then we add it back to the list, right? Because you don't want to do this manual. Like imagine like manually swapping these and then swapping. Like it's just really inefficient. Again, this has to be all of one, right? That's the entire purpose of the problem. And so the fast way to do that really is we're just going to remove the node and then we're going to add it back. Okay. And if you're wondering how the removal works, uh, we're really just swapping pointers. So we're going to basically, the way we're going to remove this is we're going to take this node, right? We're going to take node. So this points here. Let me use a different color. Sorry. I know it might be confusing. So this points here right now, right? And we actually want to point it to itself, right? And then we want to take this node and point it to node.previous, which would be nothing basically, right? So now technically this, again, we remove this connection. Now technically this node points to nothing. And so it's actually removed from our linked list. Okay. That's the removal process. And now the addition process is basically where we basically reconnect it at the start here. Sorry, I'm going a little slow or confusing. I'm just trying to mentally visualize the pointers. But we're basically just reordering the pointers such that we're disconnecting it and then we're reconnecting it here. Okay, that's really what we're doing. Okay, so that's basically how when we access stuff, what happens, right? Now, the put is a little bit more complicated in some sense, right? Because we have to update the value of the key if the key exists. Otherwise, we have to add the key value pair to the cache. Now, if the number of key exceeds the capacity, then we have to evict the least recently used key. So in terms of the put, we're basically going to check, because we're adding stuff with the put, right? The put function. So we're going to check, okay, does this key exist somewhere in this hash map? Like, let's say, right, let me try and backtrack here. Let me think of an example. Let's say we add a new key called K5, okay? Right? And our put really is a key value pair, right? So I'm gonna add. So if we have, well, technically this doesn't exist, right? Our input would be put, and then the key value pair that would be given with something like, we'll do two examples, right? We'll do K5, T6, and then we'll do K3, let's say like T2 or whatever. Okay, this example one, right? Basically, what we would do is we check, okay, this key K5, is K5 in self.cache? No, it's not, right? So what we would do is we'd basically create a node with this, right? And then we would set the key. We would do K5 here, right? And then we would add the node, we'd add the node here, right? So now we added this, okay? And then after that, we would check if our capacity is exceeded, and it was, right? Because our capacity was just 4, but now we have 5. So we would basically have to delete the least recently used node, okay? Right? Now be wary in our code. I'm just thinking about this now. In our code, like this image, the most recently used is on this side. The least recently used on this side. In our code, technically, our least recently used is just going to be on the left side, and on the right side is going to be where our most recently used is. Don't get tripped up by that. This image should be flipped technically, but I did borrow this from somebody. But yeah. Okay, that's example 1, right? Where we basically have a key that does not exist and then we add it. Now, what if we have something like this, right? So we're gonna check, okay, does this key exist in the cache? It does. So when it exists in the cache, what we're going to do is we're going to remove this node. Let me use a different color because it is green. We're gonna remove this node, right? And then we're gonna add it back with the new value T2. Okay, it could be a different value T3. It doesn't matter because we basically check where it points to and remove that, and then we add it with the new value. If it's the same value or different value, it's kind of irrelevant, but then we add this, right? Boom. Okay, and then we would check, okay, does this exceed our capacity? And it doesn't, right? Because we only have 4 in our linked list, in our W linked list. So we don't have to do anything in that instance. And I believe that's it. Okay, I believe that's it. So I hope this makes sense. I tried to explain as best I can, but yeah, we're basically just going to use a hash map and a doubly linked list, and they'll kind of work together, and we'll kind of manage what's the most recently used, what's the least recently used, and then we'll remove stuff if we need to permanently or temporarily, right? Because again, if we want to move something from here, from least recently used to most recently used, because we are adding it or we just accessed it, the way we do that is we just remove the node and then add it back on the side which is towards the most recently used. Okay, so I hope this was helpful, and now we will get to the code. Okay, now you might have a general understanding of how this will work. As you can see, right, we can't really work with nodes in this class. We don't have anything for that, so we're actually gonna have to create a class for that. We're gonna say class node, right? We're just gonna have to implement it ourselves, right? So we're gonna say int key, int val. We're gonna have pointers, 2 pointers, right? The previous and the next. And the reason for that is that, again, we're implementing a doubly linked list. Okay, so we're gonna say our node should be a key value pair, right? Key is k, key value is v, and then the pointers just pointers are just pointing to nothing. Okay. And we'll handle that when we add stuff to the actual linked list. We'll actually handle the pointers properly. Okay. So the LRU cache. Before that, we need to do some stuff. Okay. First of all, we need to we need to create a variable called capacity, right? And then down here we'll do this capacity. You can call it something else. I mean, you don't have to call it the same thing, but I just will. Okay. Just initializing it, right? Now remember, we're gonna have a hash map, right? Where it's basically a key value pair, and the key is just the value, and the value is a pointer to a node. Okay. Say unordered map. I know there's a lot of boilerplate stuff here, but fortunately we just have to do it. Okay. And also we need dummy nodes when we create our linked list, right? Because we need to actually have stuff we can reference when we're inserting for the first time, right? So we're gonna say, so when we insert a new node, it will be between the left and the right. Okay. Okay. Now, I think before we do that, we're gonna have to do okay, we'll just do this now. So for the insertion and the deletion of stuff into the W linked list, we need to have separate functions for those, right? So for example, we're gonna have a function called remove, and we're gonna have a function called add, right? This is just for the W linked list, okay? And I will write comments just for your sake, so you're not too lost. The input is just the node, right? So for removing the node from the doubly linked list, right? For example, if we have something like 1, 2, and again, this is doubly linked list, not single, but I mean, I guess I could do it like that. But yeah, it's kind of irrelevant. It's just an example. But anyways, right? So if we have something like this, right? 1 needs to point to 3, and 3 points to 1, assuming we want to remove 2, right? I'm just explaining how this is going to work, how the removal is going to work. When we pass it a node, right, we basically have to disconnect it, right? That's what it means to remove a node from a linked list, right? Doubly linked list specifically. We need to handle these pointers properly. I mean, even in a singly linked list, you would do the same. Okay, so the way we're going to do this, right? The node that we're given, right? The node before it, right? That should point to what? It should point to the current node we give it, the next one, right? So basically, we're setting this 1 pointing to this 3, and we have to do the same for the 3. And the way we would do that is we would do node next previous. That should point to node previous, right? So we're just, in this example, we're just disconnecting the 2, really, okay? Now let's handle the add, and again, also, the input is just the node, okay? Now, I will continue to write comments for your sake. So for adding the node to the doubly linked list, right? We're gonna say add to the end of the list, since we can define that as most recently used. Okay. Now, like I said in the illustration, in this picture, the most recently used is on the left side. The least recently used is on the right side. In our implementation, the least recently used will actually be on the left, and the most recently used will be over on the right. Okay, so just keep that in mind. The reason the image is like this because I actually borrowed it. I didn't create it myself. Under the image, I have the credits in case you did not notice. Okay, so we're gonna say node, right? Previous end equal to right. Previous. We're gonna say previous end is equal to node previous this end. Remember, the node that we're adding should be on the right side. Like I said, the most recently used will be on the right side. The least recently used would be on the left side. Okay. initially we really just have dummy nodes, okay? So when we have dummy nodes, right, we're gonna take right, we're gonna take right dot previous, right? Previous n is really just right dot previous. So it's pointing this way, but this is just pointing to what? It's just pointing to the left, so previous n is just left. So previous n dot next, meaning the left pointer dot next is going to be node, right? Because we basically have a left, which is just the dummy node. We have a right, which is just the dummy node. And so we're basically grabbing this. What does it point to back when it goes back? It points to this. And then we're doing this dot next should point to what? It should point to the node that we're giving it, right? And then the node that we're giving it next should point to the right. And then the right dot previous should point to the node. So basically, for the first time, in the first iteration, for example, we're just inserting stuff into the middle, okay? And then beyond that, we're just inserting stuff to the right side, okay? So I hope that makes sense. I know it's a little confusing working with a bunch of pointers like that, but it's just doubly linked list. That's just how linked lists are, my friends. So we have the remove function on the add function for the doubly linked list. That's good. Now we can actually get to the problem. We just have to set up the node stuff, which is, it's kind of annoying, but I mean, it's just the efficient way to approach this problem. So now we just set the capacity. Let's check our constructor here. What do we have to do? Do we have to do anything else? Well, we actually have to set the node here. Actually, should have done this before. I'm reading some of my code that I have on my other screen just because I don't think I could. I mean, I could memorize this, and I do memorize it to some degree, but I don't want to just like have really long pauses. Okay. I don't want to have really long pauses while I solve this. So in case you were confused what I'm talking about here, it's because of what we do here with the setup, right? Our left node, maybe I'll just use a comment. For the first time, right? Our left node is just -1, -1, right? These are just dummy nodes, right? Our right node is -1, -1, right? These are dummy nodes that we're setting up, and the left dot next points to the right, and the right dot previous points back. So these are just basically what it looks like before we even add anything, right? So what I'm saying in terms of how this is going to work for the first time, right, is we're going to do previous.end is going to be what? Previous.end is going to be set to right.previous. Well, right.previous is just basically the left, okay? So when we do previous.next, right, this is going to basically, the left is just going to point to the new node, okay? And node.previous, when it goes back, it should point to the left. And then so we connected the new node to the left, right? Because this new node really will be where it'll be right here in between, right? Right. If we had a node like 2, or something, the node would be right here. So basically, we connected this part, right? We set the connections up properly. Points this way, and this points back, and we do the same with this. Okay. That's why the dummy nodes are important, because we do the insertion kind of in the middle. Okay. And then all the new nodes get put right here. Okay. Yeah, I hope that's not too confusing. Sorry if that confused you, but yeah. It's just hard to kind of write the code and explain visually. It's kind of a pain, but I mean, like I said, pointers. It's just pointer stuff. But yeah, these are basically just setting up the dummy stuff. Right. Okay, so I mean, technically this comment, I could just write it down here as well, because it's this dummy stuff, we're finished. We create the nodes, but we actually finish setting it up right here, the dummy nodes. Okay, so that's the constructor. Okay, we're basically just setting up the dummy nodes and then setting the capacity properly. That's all we're doing. Now for the get function, okay, and I will write comments for this, because this can be kind of a lot to take in at once. Because the issue with this problem is there's just a lot of steps. It's not necessarily that this problem is super hard as step by step, but it's just there's so many steps and it kind of adds up. And it can be kind of confusing. Okay, so we're gonna say when. Right, let's just read the get function first, right? We have to return the value of the key if it exists. Otherwise, we have to return negative 1, right? So when we get a value, we need to put it to the end of the doubly linked list, right? Because when we call the get function, we're accessing something, right? So now whatever we're getting, if it exists, whatever we're getting, it should be put to the most recently used now. And if it doesn't exist, then it doesn't matter because we're just returning a -1, right? But if it does exist, it's now our most recently used. So we need to actually do that or handle that, okay? So we need to put it to the end of the doubly linked list to mark it as most recently used. Then we can finally return its value. And this is all assuming it exists, right? So first of all, let's just handle the case where it doesn't exist, right? Because that's pretty simple. I mean, if it doesn't exist, it doesn't exist. And that's the case where we basically just return -1. Okay. Now, if it does exist, we're returning the value. Okay, so, okay. But beyond just that, we need to do something. Remember, we need to basically remove it from our linked list and add it back. Because when we add it back, we're adding it back to the end, right, of the doubly linked list. So that's where our most recently used is going to be. Okay. So we're going to say node, right, hash key. We're going to get the reference to whatever that node is, right? And then we're going to remove that node, and then we're going to add it back. Boom. So now it'll put the node in the proper place in the doubly linked list. And so now this node will be the most recently used. Okay. Now let's handle the put function. Okay. So we'll read this first, right? So we have to update the value of the key if the key exists. In our input, we have a key and a value. It is possible that the key that we're given, the value in the input is the same as the value that's already in our doubly linked list, but it could not be the case also. But in either case, whether the value is the same or not for this input, we're going to overwrite it, right, given the key that we have. Now, if the key doesn't exist in the hash map, we're just going to create the key value pair and add it to the cache. And after we're done with all that, we're going to check if the number of keys exceeds the capacity. And if it does, then we need to remove the least recently used key. Okay. So in terms of how we're going to handle this, we're going to say if the key exists, if the key already exists, remove the node and add back the new node with the given value. Because this is outside. Because this is a new sentence, by the way. I know it might be, don't read it as all the same sentence. I'll just do a capital B. Because this is outside of the if statement, and you'll see in our code what I mean by this, we create the node regardless if it exists or not without issue, right? Because we're gonna have first of all, we're gonna have an if statement to check if this key exists. So we're gonna say cache.find key. Let's say cache.end. Right. So if this key exists, we're gonna store this reference to the node in old node. Let's say cache.key. Okay. And now we can call what? Remove, right? We want to remove this node. Also, I shouldn't use. Let me see. Did I use underscore? I really shouldn't do that. We're on C++. We'll just stick to good habits. So I apologize. Sometimes I rewrite my code in C++ and I don't pay attention because I do these videos on Python first. Let's see, do I have a? Okay, that I have to do. Okay. So we're getting the old node that we want to remove, and then we remove it. Why are we doing that? Because the key already exists, right? But the reason we want to remove the old node is because this value in our input is not necessarily the same. It could be a different value. So we just want to remove the node and add a new node with this value now. Because the key could be whatever, k1. Well, it has to be an int. The key could be 1, and the value already in the doubly linked list could be like 5. But this input that we're given could be like 1, and the value could be like 7, right? So we actually have to remove this node and then add it back with this value, okay? So I'm gonna say node, and what I'm saying here, we create the node regardless of whether it exists or not. What I'm saying here is if we're not in here, we're gonna create the key anyways, right? With the given value. So regardless of whether it exists or not, we're gonna handle it, is what I'm saying. Okay, so we're gonna say new node, and we have key value pair for our input, right? We're gonna say cache key node, right? And then we add the node. Okay. Now remember, we have to actually handle the capacity as well. Capacity exceeded. If that's the case, so we're gonna have to have a check. We're gonna say if cache.size is greater than the capacity, then we need to handle it. Now, how do we handle this when we have capacity overload? Basically, we need to remove the least recently used element, and we should be fine, right? Because if we added a new node, now we're basically have too much capacity. Just remove the least recently used thing from the cache, and that's it. We're good. We're gonna say node delete node. Remember, like I said, in our actual code, the left side has the least recently used stuff. And the right side has the most recent, or most recently used. Okay. So we have to basically get left.next to get the least recently used. And that is the node that we're going to delete. Let's say remove delete node. Let's say cache.erase delete node key, right? Because we have to actually remove it from our hash map. We're removing the node, and we're actually removing the key as well. Okay. And I believe that's it. I believe that is it. Line 14. Right, this is a class, so we need a semicolon. We got a semicolon here. Little syntax errors. Yeah, there is a lot of code here, man. I don't know where I got the left from. I might have added this by accident. I don't know if it was in my comments. Let me space this out so I don't mess you up. So you can handle the steps. Setting the left, connecting the left and then the right. Okay, like each step in the process of adding a new node. Okay. So yeah, I think this should be it. Yeah, that's it. Okay. I'll go scroll up, right? Our node class right here. This is just some stuff we have to set up. With the nodes, the dummy node, setting up the hash map. Set up the capacity stuff, the dummy nodes. This is the get function. This is the put function. And then this is the removing and adding stuff for the actual doubly linked list. I think as a whole, it's not that this problem is difficult. I think the difficulty in this problem is there's so many steps and things you have to account for that when you try and take it all in at once, it can be overwhelming. So if you're still lost on this problem, try another video. Maybe someone explains it better for your liking. But also, I think if you're lost, my advice is just take everything one step at a time, right? Set up your hash map. Learn how you're setting up your doubly linked list. how you're adding stuff, removing stuff from the W linked list, and then focus on the actual implementation stuff. Because you have to do some setup first, right? Before you actually implement this class with the nodes and stuff, which is, yeah, I think this problem is actually quite hard, especially if you've never seen it. I don't know how you would ever solve this unless you're really, really smart or you've done a lot of similar problems already. But yeah, this problem was a little bit difficult to get on your own, so don't feel too bad. Don't feel too bad if you can't do it. You didn't get too far on your own. But yeah, I hope this helped, and I'll see you in the next one. Peace out.